in the concept of the mesh analysis. Now let us see the concept of the super mesh analysis here. So when do we apply the concept of the super mesh is, suppose the current source is common between the any of the two meshes. So this current source is common between the this mesh and the this mesh. We are going to call this as a super mesh. We are going to call here, and we are going to apply the super mesh analysis, and we are going to denote with the dotted lines. We'll see the procedure. So before going for starting the problem, so what we'll do is, so you can see the 15 amperes is in parallel with the 4 ohms. Let us perform the source transformation for this one, and let us convert this into the single loop network. Let us do convert here. So I'll rewrite the circuit diagram. The circuit diagram will consist of, so like this. So here we have the 6 ohm resistor. So when you apply the perform the source transformation, this will become the voltage source in series with the resistance will get, and 2 ohm resistance in series with the 30 volts power supply. And here we have the voltage source, and here we have the other one, and this is the 12 ohms power supply. 12 ohms is there, and this is plus minus 180 volts, and this is the 24 volts. In between we have the current source. So we have the 45 ampere current source. This is the 6 ohm, and when you perform the source transformation, so 15 fours are, this will become 60 volts, and this is 4 ohm, this is 2 ohm, and this is 30 volts will get. So this is how we got the circuit diagram applying the concept of the source transformation. Now let us see the concept of the super mesh analysis. So here we are going to call it as a super mesh when there is a current source, it's a common between any of the two nodes, two meshes. We are going to call it as a super mesh, and we are going to denote that super mesh with the dotted lines. We are going to denote here. So like this, we are going to denote with the dotted lines. So here the current in this mesh one, we are going to call it as it's I1. The current in this mesh, we are going to call it as I2, and the current in this mesh, we are going to call it as I3. We are going to call, and since the current source is common between the mesh 1 and mesh 2, we are going to call this as a super mesh. We are going to call here, and we need to write the constraint equation. The constraint equation is the Timat equation, which is going to represent the common current source between the two meshes in terms of the mesh current. That is called as a constraint equation. We are going to call. So let us write that one. So it is called as a constraint equation. So we are going to represent that one. So here the constraint equation we are going to express in terms of the power supply is there. It is having the direction like this. So 45 amperes. The same direction current minus the opposite direction current will take here. That is I1. So we are going to take that as I1 minus I1 plus I2 will take. So it's minus I1. Since the direction of I1 is opposite to the 45 ohms, that's why I'm taking with the negative. Minus I1 plus I2 is equal to the 45 amperes. Let us call this as a equation 1 here. So this is the first procedure we need to do. First, we need to identify if a current source is common between the two meshes. We are going to call that as the super mesh. We are going to call, and we are going to identify that one. So now, what shall we do is we'll apply the Kirchhoff's voltage law. The mesh analysis KVL we are going to apply for the super mesh simultaneously. We are going to apply here. So we'll apply the KVL for super mesh simultaneously. We are going to apply. We'll apply the KVL for the super mesh simultaneously. We are going to apply. So we'll start from the 64 volts power supply. So here the current I1 is entering 60 volts power supply. The current I1 is entering 60. So it is raising the voltage. So minus the drop across this one is. So when applying the KVL for the super mesh, we are not going to consider this current 45 amps. Will not consider. So minus 6 into the, and the current entering positive leaving negative, it's a drop in the voltage. So it's a minus 180, and the drop across this one is, it's a 24 ohm resistors. So minus 24 into the two currents are flowing, one is I2 and I3. So it is I2 minus I3, and here the current entering positive leaving negative, it's a drop in the voltage, again the minus 30. And let us the drop across the 2 plus 4 is it's a 6 ohm resistor. So it is minus 6 into I1 is equal to 0. Minus 6 into I1 is equal to 0. Now let us find the equivalent values here. So 4 plus 2, 6 ohms are there. So in this one, we have the 6I1 will get, and in the mesh 2, we have 6 is there, plus 6I2. Sorry, 6 plus 24 is there. So it will become 30I2 will get here. So 6 plus 4, 24, it is a 30I2. And between the mesh 2 and mesh 3, the 24 ohms is there. So it is a 24 I3 is equal to, now let us consider the polarity of the source here. So 180 minus 60 minus 180, it will become minus 120, minus 120 minus 30 will become minus 150 will get. So this is minus 150, call this as the equation number 2 here. So we got, by applying the KVL for the super mesh, we applied, and we got the expression for the this power supply, this mesh 2 we got here. Now what we need to do is we need to apply the KVL for the mesh 3. Let us apply the KVL for the mesh 3. So in order to get the mesh current here, so we'll apply the KVL for the mesh 3. So KVL for the mesh 3, let us apply here, and let us find the expression for the mesh current analysis. Let us find out here. So in order to apply the KVL, we'll start from the 12 ohms power supply. So it's a minus 12 into I3, minus 12 into I3, and here let us come to 24 ohms. So the two currents are flowing, one is 24, the I3 and I2. So when you are applying the KVL here, so it is the mesh 3 current, so minus 24 into, that is I3 minus I2, the mesh 3 current minus the mesh 2 current we are going to apply. And here the current entering negative, leaving positive, it's a rise in the voltage, plus 180 is equal to 0. So let us simplify this one. When you simplify here, so it will become minus 24 I2 plus the two resistance are there in the mesh 2. One is 12 and mesh 3. It is 12 and 24. So this will become, so it's a 36 I3 is equal to the 180 will get. So call this as the equation number 3 here. So by applying the first, we got the constraint equation. What we have done is we express the current source between the two meshes in terms of the mesh currents we expressed here, and we got this one. And by applying the KL for the super mesh simultaneously, we got this one. And by applying the KL for the mesh 3, we got this one. Let us express these equations in the matrix form 1 in the matrix format. So the equation 1, we have I1 term, I2 term, so that is minus 1, 1, and we don't have I3 term, 0. And from the equation 2, we have 6, so 30 and minus 24. From the equation 3, we have 0, so minus 24, and 36 we have. And from the mesh currents, we have I1, I2, and I3 we have. And this is equal to the corresponding voltages are, so it is 45, and from the equation 2 it is minus 150, and from the equation 3 it is 180 we have. So this is what we have, the set of equations. These are the set of the equations we got here. Now in order to solve this one, let us apply the Cramer's rule. We can apply here, or we can apply this one. By using the matrix, we can do simplify. So I1 is equal to delta 1 by delta. So let us take the calculator. So since it does not contain any AC terms, so we'll go for the calculator with the 3 unknowns we'll go. So let us substitute in the calculator minus 1, 1, and 0. And for the this one it is 45. And from the equation 2 it is 6, 30 minus 24 and minus 150. And from the equation 3 we have 0, so minus 24, 36 and 180. And we got the value for the mesh currents we got, that is I1 will be equal to the, so minus 33 amperes we got. And also we got the expression for the I2 is nothing but it's a delta 2 divided by the delta. So the value for the I2 it is 12 amperes. From I3 we got, so it is equal to the, So the value for the I3 will be equal to the, so the value for the I3 is equal to the, so we got here, it is 1.3 ohms will get, 1.3 amperes will get. That is the value 3 we get. So we got the value for the I3 we got here. So it is the 1.3 amps we got. So the value for the I3, so it is equal to the delta 3 divided by delta. So this is equal to the, so this is how we got the values for this one. And in this problem, let us find out the power dissipation in the 13 in the circuit diagram. We have the 12 ohm resistor is there. 12 ohm resistor is there. We need to find out the power dissipation in the 12 ohm resistor. Let us find out that one. So here the mesh current is I3 is flowing here. 12 ohm resistor, the current I3 is flowing. So let us find out the power dissipation in the 12 ohm resistor. So power dissipation in the 12 ohm resistor. So it is P12. It is nothing but I square into R. So I is nothing but it is the current I3 square into R. So it is 13 square into the resistance is 12 ohms. So it is so let us change the calculator mode. So 13 square into 12. So this is become the 2028 watts will get here. This is how the power has been dissipated in the resistance 12 ohms here.